All right, so number 10. What are we on? 11.3? 7.3. Number 10. Okay, so here we go. Number 10 is the one with the cart. So here's the deal with number 10. It says a cart has a total mass of 2.4 kilograms. So the mass of the body and the wheels combined is 2.4 kilograms. All right? The problem says that it has 4 wheels, which are solid discs, each with a mass of 0.25 kilograms. So the mass of just the wheels is 4 wheels times 0.25 kilograms for a total of 1 kilogram. So that means that the mass of the body by itself must be 1.4 kilograms. I don't know that you have to know that. There are ways you can use that though. All right? So here's what we know. The cart is rolling at 5.2 meters a second when it encounters a hill inclined at 42 degrees. Wow, I can't draw triangles today. 42 degrees. All right, so when the cart gets to here, the height is 0, but the velocity is 5.2 meters a second. Question A says, how far will the car go up the hill before it stops and rolls back down? So here at point A, the question is, how far has it rolled, right? So do you guys understand that if I can find the height, then I can find how far it rolled, just like we did in the pinball problem a minute ago? Okay, so if I can find this height, I'm good. What else do I know at that point, you guys? Velocity is 0. Cool? All right, so once again, let's call this point S as in start, and we're looking for the height at point A. Follow? All right, so it is true that the total energy at the start has got to equal the total energy at point A. So total energy at the start. Well, what kinds of energy do we have down there, you guys? Somebody said something. I just heard E, the E part of it, though. What'd you say? KE? Okay. So kinetic energy. So when I find the kinetic energy there at the start, which of the 3 masses am I going to use? The whole thing, the full 2.4 kilograms, right? So the body and the wheels. Okay, what other type of energy do we have? Rotational kinetic energy. What mass do I use there? Just the wheels. Let's see, GPE there is 0. That's it, right? Okay. At point A, what type of energy do we have? Just GPE, right? How much mass has GPE? The whole thing, body and wheels. Cool? So the kinetic energy of the body and the wheels. So that's 1/2. Mass of the body and the wheels is 2.4. Velocity is 5.2. Don't forget to square it. So kinetic energy, kinetic energy. Follow? Plus, nope, damn it. Plus, God bless it, stupid. Plus, there we go. All right, don't laugh at me. All right, rotational kinetic energy. So remember, you guys, the rotational kinetic energy is just B times the kinetic energy. So the kinetic energy of the wheels would be 1/2. What mass do I use? 1 kilogram, because that's the mass of the wheels, times 5.2 squared. All right, so that right there is the kinetic energy of the wheels, but I really want the rotational kinetic energy of the wheels. So now what do I multiply by? B. Oh, we haven't established what B is. What does the problem tell us about the wheels?
Discs.
They're shaped like discs, right? So I, for a disc, is 1/2 mr squared. So what's B, you guys? 1/2.
Yes.
Okay? So this is my RKE. Follow? Any problems? Equals the GPE, which is the mass of the body and the wheels times 9.8 times the height. That's not me crossing stuff out. That's me highlighting stuff. I hope you guys understood what's going on there with the colors. All right, are we good? All right, and then solve it. I mean, on the left side of this is just plug all this garbage into your calculator, right? Down here you get 23 point something or other, and divide, and you get your h. Cool? Does anybody know what that h turns out to be if you solve it? Anybody ever written it down? That rings a bell with me. 1.66 meters? Okay, cool. So now I can do a little bit of trig and find how far it rolled, right? 1.66. Here's my angle of 42 degrees. So now I can find my displacement just by dividing by the sine of 42, right? Cool. Questions with with number 10A? Is everybody good? All right. Part B. How fast will it be moving when it has rolled half of this distance? Ugh. All right. So the idea is somewhere in here there's a point B when it's gone half of that distance. Question or answer or what?
Well, actually, just keep going and it'll come.
You sure?
Yeah.
Okay. So first of all, it doesn't turn out to be just half the velocity, unfortunately. Yeah, boo, I know. Yes, stupid kinetic energy. Yeah, it doesn't work that way. Okay? And the reason is because it's moving faster at the beginning, so it has less time to lose speed during the first half than it does in the second half. So it should be more than half the speed. All right, so do you guys agree that half of the distance would also be half of the height? Is that what you were going to ask?
Yeah.
Great. Okay, so now what we know then is the total energy at some point equals the total energy at this new point B. So what do you guys want to do? Do you want to do... What the bleep just happened? Oh, there we go. So do we want to do... I guess it would probably be easier to just do point A, right? Because we just found our height, 1.66. And all of it is GPE, right? So let's do that. The total energy at A is equal to the total energy at B. And the total energy at A is the mass times 9.8 times 1.66, right? Follow? All right, and that's got to equal the total energy at B, which is the GPE at B plus the kinetic energy at B plus the rotational kinetic energy at B. I would discourage you from doing total kinetic energy because the body of the cart doesn't have rotational kinetic energy. So you really got to separate it. Does that make sense, you guys?
Yeah.
All right. So, so this whole mess. What, seriously? Why that keeps happening lately? All right. So this whole mess is a number. Does anybody know what that gives you? 2.44. Nope. Times 9.8 times 1.66. 39.0. Let's just call it 39 for simplicity. Equals. All right. GPE at point B. Well, same mass, same 9.8, but half of the height, right? No, 0.83, sorry. So there's the GPE, right? Plus, all right, talk to me, you guys, about KE. 1/2 what? Total mass times v squared. So that's my KE. Notice I used the total mass because the body and the wheels have kinetic energy. Plus RKE. So that's B times KE. So our B is 1/2. KE is 1/2. What mass do I use here, you guys? 1, because that's the mass of the wheels, right? And then solve that mess for V. Cool, you guys, or no? Any problems? Going once? Twice? Sold. All right, so